Good day, everyone. Now, today we are going to be talking about vector analysis. Vector analysis. We all know that scalar quantities are quantities that has only magnitude but no direction, while vector quantities are quantities that have both magnitude and direction. So, since scalar quantities has only magnitude but no direction, so if you want to add or subtract two or more scalar quantities together, we are going to use simple arithmetic. Like if we have 2 meter plus 2 plus 3 meter, that can be 5 meter. If we have 3 kg plus 5 kg, that can be 8 kg. But if you are talking about vector analysis, we are going to be considering the addition of two or more vectors. We are going to be considering both the magnitude and the direction. So the reason why we cannot add two vectors by simple arithmetic is because whenever we are adding two vectors together, we have to consider both magnitude and the what and the direction. So the process of adding or subtracting vectors quantities, two or more vectors together, that process is known as vector analysis or vector resolution. So after the addition of two or more vectors, a single vector would be derived, would be gotten. And that single vector is known as resultant. So this single vector will have the same magnitude and direction as the vectors added together. So the direction will also be gotten by what? By an angle. So let's look at the different cases under vector analysis. Now, the first case one is that when two vectors are parallel to each other in the same direction, the angle between them is 0 degrees. So the angle between two parallel vectors is what? 0 degree. And if you want to get the resultant of two parallel vector, you are going to add the two vectors together. So that's how you are going to do for what? Two parallel vectors. But when we have two vectors that are anti-parallel, that is, that are opposite to each other, so their resultants will be gotten by the subtraction, either F1 minus F2 or F2 minus F1. So you are going to be subtracting, you are going to be writing the highest force before the smallest force. So that is why it can be F1 minus F2 or F2 minus F1. So case 3 is that when two vectors are perpendicular to each other, the angle between them will be what? 90 degrees. So when two vectors are perpendicular, the angle between them is 90 degrees. But when they are parallel, the angle between them is what? 0. So if you want to calculate the resultant of two perpendicular vector, we have to use the Pythagoras theorem, which says that R resultant will be equal to square root F1 square plus F2 square. Okay, now we can also get the direction of the two forces, the direction with which the resultant makes with the forces. So by using the tan theta is equal to F1 over what? F2. So the theta that's going to be gotten will be the angle to the horizontal. So let's look at a particular example to understand more better. In this example, if an object is acted upon by two forces, 5 Newton and 12 Newton, write solution. Then write out the parameters given to you. Our F1 is equals to 5 Newton. Our F2 is equals to 12 Newton. Calculate the resultant of the two forces. Number one, if the forces are parallel to each other, you just say that, number one, for parallel forces, the resultant will be equals to the addition F1 plus F2. So therefore, the resultant R will be equals to 5 plus 12, and that's equals to 17 Newton. So the resultant of these two parallel forces will be the addition, and the answer is what? 17 Newton. So if the forces are anti-parallel, for anti-parallel, that simply means that they are not parallel, they are basically opposite. So for the anti-parallel, we are going to be subtracting the two forces together. So the resultant will either be F1 minus F2 or R is equals to F2 minus F1. You know, it can either be F1 minus F2 or F2 minus F1, depending on the force that is greater. Since F2 is greater than F1, then we are going to be using F2 minus F1. So therefore, our R will be equals to 12 minus 5, and that's equals to 7 Newton. So the last question is that the forces acting, if the forces acting on them is what? Perpendicular. So we are going to say that for perpendicular, this simply means we have to use the formula R is equals to square root F1 squared plus F2 squared. So our R will be equals to square root, our F1 is 5 squared plus our F2 is 12 squared. So this will equals to square root, 5 squared is 25 and 12 square is 144. 144. So therefore, our R will be equals to square root 169, and this is equals to 13 Newton. So that is the resultant. But for this perpendicular force, we can also calculate the what? The direction with which the resultant is going to make with either angle 1 or with either force 1 or force 2. Let's look at this. So you will just draw something like this. Draw a perpendicular like this. This is the angle 90. So let me just assume that this is my F1, this is my F2. So since F1 is 5 Newton, so I can say that I can just represent this as 5, this as 12. So if you also wish, you can represent this as 12, this as 5. So no matter what you want to do, you can just do it like that. Now, the next thing we're not going to do is that the points where this meets, where the two forces meet, will be the point that we are going to draw your what? Your resultant. So this will be your resultant. This is your resultant. So therefore, you are going to draw your resultant from this point. This is your resultant. Then this will be the angle theta. This is angle theta. So you can then trace this up. You can trace this. So this will be equals to this. This will also be 12. You can also trace this down. This will also be equals to this. This will also be 5. So I can just bring, you are going to see that the part up will be the same as the part down. So I can just bring a part out, this part. I can just bring it out like this. I just brought 1/2 of this out. So this will be theta. Then this will be R. And my R is 13. So I'm going to replace this as 13. So this one will be 5. Then this one will be 12. So what I want to look for now is this theta. So if I want to do that, so if I want to get a angle theta, I will say that tan theta is equal to opposite over adjacent. This is my opposite. This is my adjacent, 5/12. So therefore, tan theta is equal to 5/12. The theta is equal to what? Tan inverse 5/12. The value for this theta will be the direction of the resultant that it makes with the what? With this horizontal. So guys, case 3. When the angle between two forces is acute, that is less than 90, the resultant will be calculated by the trigonometric formula R is equal to square root F1 square plus F2 square plus 2F1 F2 cos theta. Why case 4? When the angle between the forces is obtuse, that is to say greater than 90, then the resultant will be calculated by this. So this simply means that the formula for case 3 and case 4, they are the same. But what you have to note is that depending on what you know or what you've learned before, whenever you are using this particular formula, you should not change any parameter. Don't change any sign. Let it be plus, 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 plus. So let's look at how we can apply this in a particular question. If two forces, 5 Newton and 12 Newton, acted upon a box, calculate the resultant if the two forces are acting at 40 degrees to each other, and if the two forces are acting at 125 degrees to each other. This 40 degrees is less than 90, so it is an example of case 3. This 125 degree is greater than 90, it's an example of what? Case 4. So in each case, we are going to be using the same formula directly without changing any parameter. Don't change any sign. So your R will just be equal to square root F1 square plus F2 square plus 2F1 F2 cos theta. Our F1 is 5, our F2 is 12. So this will be 5 square plus 12 square plus 2 times 5 times 12 cos 40, because the first angle given to us is what? 40. You are going to get this. And also, if you use the same formula and use cos 125, the second angle, then you are going to get this. So that is how to do it, guys. Now let's move on to case 5. Case 5 is now. Okay, guys, case 5 now is that. Okay. So for case 5, this involves two or more forces acting at a point. The resultant and direction involves the step below. Now, if we have two or more forces that is acting at a particular point, then we can calculate the resultant and the direction by following some particular steps. The first step is that we should firstly indicate the plus x-axis minus x-axis plus y-axis minus y-axis. After that, we should convert all angles given to the horizontal. If the angle is already to the horizontal, we should leave it. But if the angle is to the vertical, we should convert that angle back to the horizontal. And if you want to convert an angle from vertical to the horizontal, just minus that angle from 90, and you will get the value to the what? Horizontal. The next one is that we should resolve each forces to the horizontal and vertical direction. So if you want to resolve a particular force to the horizontal direction, we are going to take cosine. But if you want to resolve to the vertical direction, we are going to take sine. So after we have resolved to the horizontal and vertical direction, the next thing we are now going to do now is that we are going to add all the horizontal directions together. We will also add all the vertical directions together. The horizontal direction will be known as summation x. The vertical direction will be referred to as summation y. So after that, we are now going to calculate the resultant by using r is equals to square root summation x squared plus summation y squared. And we also calculate the direction to the horizontal by using theta is equals to tan inverse summation y over summation x. Now let's look at a particular example. So guys, in this example, we have this diagram. The question now says, in the figure shown above, calculate the resultant of the forces on the objects. Now guys, if you want to do this, this involves 3 or more forces. So whenever we want to calculate the resultant and the direction of 3 or more forces acting on a particular point, then we are to use the process that we've explained before. The first process is that we are going to indicate the positive axis and the negative axis. And if we want to do this, we are to redraw this diagram. We are going to redraw this diagram as this. Step 1. We are going to redraw this diagram as this. Now, once we've redrawn this diagram, we are going to indicate the positive x-axis, the positive y-axis, the negative x-axis, the negative y-axis. The horizontal direction represents the x-axis. The vertical direction represents the y-axis. So therefore, guys, now the upward direction will be the positive y-axis. The downward will be the negative y-axis. The right direction will be the positive x-axis. The left direction will be the negative x-axis. So once we've done this, we are now going to indicate all the parameters here. So this will be 3 root 3 Newton. This 10 Newton. This 3 Newton. This 6 Newton. Now, once we've done this, the next step is, don't forget that the first step is that we should indicate the positive x-axis, positive y-axis, negative x-axis, negative y-axis. The next step now is that we should convert all the angles to the horizontal. We are going to check for all the angles in this question. If there is any angle that is to the vertical, we are going to convert it to the horizontal. But if there is any angle that is already to the horizontal, we will not touch it. So if you look at the first angle here, this is 60 degrees. Don't forget that this 60 degree is to the vertical direction. This 60 degree is to the vertical direction. So we need to convert this 60 degree that is to the vertical direction back to the horizontal. And if we want to convert an angle from the vertical direction to the horizontal, we are going to minus that angle from what? From 90. So everybody, what is 60 minus 90? 90 minus 60, that is what? 30. So this simply means that this angle we converted back to the horizontal, and we are going to write it here as what? 30 degree. So we've successfully converted this angle back to the what? Horizontal. After we've done that, we are also going to look for the next angle. The next angle here is 60 degree. We're now going to check that, is this 60 degree, is it to the horizontal or to the vertical? We are going to say that this 60 degree is already to the horizontal, so we will not do anything with it. So you will just write it to the horizontal, 60 degree. So we are done with this, guys. Now the next thing we are not going to do now is that we are not going to resolve all the forces to the what? We are going to resolve all the forces, each forces to the what? To the horizontal direction and the what? Vertical direction. How are you going to resolve to the horizontal direction and the vertical direction? Let's do this, guys. Let's do this table. So we are going to say this is forces. This is horizontal direction, vertical direction. So guys, if you look at this, we are going to draw the table like this. We are going to write out the forces, horizontal direction, vertical direction. We are going to say that in this particular diagram, we have 4 forces. This is the first force, Newton 1. This is the second force, this is the third force, and this is the fourth force. So the forces, we are going to write it out. 3 root 3 Newton, 10 Newton, 3 Newton, or 6 Newton. Now, once we've written this out, the next thing we're not going to do now is that we're not going to be resolving each forces to the horizontal direction and what? Vertical direction. Now, guys, look at this. The first force we have here is still root 3 Newton. Because that this thing root 3 Newton is going only in vertical direction. It is going only upward. It has no horizontal direction. So therefore, this simply means that this thing root 3 Newton has only vertical direction. There is no horizontal direction because it is going only upward. It is going upward directly. It is not moving in any direction horizontally. So we are going to say that the horizontal direction for 3 root 3 Newton is 0. It has no horizontal direction. So, but the vertical direction is what? Is 3 root 3 Newton. So, since it is going vertical direction, it is plus 3 root 3. So, this will be plus 3 root 3 Newton. So, that is that for the what? 3 root 3 Newton. Now, the next one, guys, is 10 Newton. We are going to see that this 10 Newton is actually going in a particular direction like this. This means that this 10 Newton, I can either resolve it to the horizontal or I resolve it to the vertical. Because this 10 Newton is going in a direction like this, right? So I can move this 10 Newton, I can resolve it to the horizontal or I resolve it to the vertical. So if I want to resolve this 10 Newton to the horizontal, I'm going to be taking the cos. But if I want to resolve it to the vertical, I'm going to be taking the sine. So if I want to resolve this to the horizontal now, I'm going to do it as this is the 10 Newton. I'm going to write 10. Because don't forget that whenever we are resolving to the horizontal, we have to take what? Cos. And then write 10 cos. I will not look for the angle. The angle is what? 30 degree. This will be 10 cos 30 degree. Now, before I move, I will now check that, okay, if I'm resolving this 10 Newton to the horizontal, am I resolving it to the plus horizontal or the minus horizontal? You're going to say that if I want to resolve this 10 Newton to the horizontal, I'm going to be resolving it to the what? Plus horizontal. So I'm going to place plus here. Do you get that? Now, we will also resolve this 10 Newton to the vertical. So, whenever I'm resolving to the vertical, I'm to take the what? The sine. So, I'm going to write it as 10 sine. I also look at what's the angle for this 10. That is 30. 10 sine 30. Now, I also look at, am I resolving it to the plus vertical or the minus vertical? I'm resolving it to the plus vertical. So, here will be plus. Now, once I'm done with this, I'm going to look at this 3 Newton. You will also see that this 3 Newton is only moving on the horizontal direction. It is not moving in the vertical direction. So this 3 Newton has only horizontal direction. There is no vertical direction. So this 3 Newton, it has only horizontal direction and it is moving in plus horizontal direction. So it will be plus 3 Newton. But the vertical direction will be what? 0. Okay? And the last force is 6 Newton. You're going to see that this 6 Newton is moving in this direction. So I can either resolve this 6 Newton to the horizontal or I resolve this 6 Newton, to the vertical, or I resolve this Newton to the horizontal. If I'm resolving this 6 Newton to the horizontal, I'm going to be taking cos. So it will be 6 cos. The angle is 60. So that will be 6 cos 60 degree. Now I will now check that am I resolving it to the positive horizontal or the negative horizontal. You're going to see that if I should resolve this 6 Newton, I'm going to be resolving it to the negative horizontal. So I'm going to put the minus here. And also, I'm going to resolve this 6 Newton to the vertical direction. You're going to see that if I should resolve this 6 Newton to the vertical to the vertical direction, I'm going to write that 6 sine 60. And don't forget that I'm resolving it to the negative vertical, right? So this will be what? Minus 6 sine 60. So guys, so the 10 cos 30 will give us 5 root 3. Prepare your calculator. 10 sin 30 will give us 5. Minus 6 cos 60 will give us minus 3. Minus 6 sin 60 will give us what? Minus 3 root 3. So I'm going to do the total. I'm going to add all the horizontal directions together. That is summation x. I got this. Add all the vertical direction together. That is summation y. I got this. So once I'm done with this, I will then move on to calculate my what? Resultant. So guys, we are going to say that if summation x is plus 5 root 3 Newton, summation y is plus 5 Newton, according to the calculation we did last. So we are going to get our result by using square root summation x square plus summation y square. So our summation x is 5 root 2, that will be 5 root 3 square plus 5 square. Then we are going to get our R to be what? 10 Newton. Then guys, we will now draw the vector or diagram. The vector diagram will not be this. You will see that when we are explaining the positive x-axis, positive y-axis, negative x-axis, negative y-axis, you've known that if it is positive y, it will be going up. But if it is positive, if it is negative y, it will be coming down. If it is positive x, it will be going to the right. If it is negative x, it will be coming to the left. Since our summation x, that is the summation of the horizontal direction, is positive, this simply means that it will be going to the right like this. So that is 5 root 3. And since our positive y, our summation y is also plus, this simply means that it will also be going to the what? It will also be going up like this. So this will be what? 5 Newton. So therefore, this simply means that the joining of this can be the resultant, which is then equals to what? 10 Newton. So I can say that this is my theta, this is my angle 90. So in order to get the direction, I can just say that theta is equals to tan inverse summation y over summation x. Don't forget that this is summation y and this is summation x. So this will now be equals to tan inverse summation y is what? That is 5 over summation x is 5 root 3. And the answer will give me what? 30 degree. So this is my direction, this is my resultant. So okay guys, in this example, the question says that an insect is displaced on a straight track joining the base and the apex of 2 vertical poles. This simply means that we have one vertical pole here, we have another vertical pole here. 2 vertical poles, each 2 meters. This simply means that they are of the same height. This one is 2 meters, this is also 2 meters. And 3 meters apart. This simply means that the distance between them is 3 meters. They are apart, 3 meters apart. This distance is 3 meters. Calculate the straight track joining the insect together. So for what we have here, we can just draw something like this. This will be representing their what? Their resultants. This is representing the resultant. So we can just bring out half of this as this. So this will be the resultant. This is angle 90. This can be theta. And this is 2 meters. This is 3 meters. Then we can calculate the resultant. For question 1, they say we calculate the straight track covered by the insect. So that is question 1. We just calculate the resultant. So calculating the resultant for right angle triangle, that is angle 90, we are going to be using the formula r is equal to square root f1 squared plus f2 squared. So this will be square roots. My f1 is 2, that is 2 squared plus 3 squared. And this equals to square root. What is 2 squared? 4 plus 9. What is 9 plus 4? That is what? 13. So our r is equals to square root 13. So if I want to calculate the and the angle above the horizontal will be this theta. So that is, I will just use theta is equals to tan inverse summation y over summation x. Theta is equals to tan inverse summation y, that is horizontal, that is 3. Sorry, summation y, that is vertical, that is 2. And summation x, that is horizontal, that is 3. So my theta equals my theta will equals 33.7 degree. And this simplified can give me 3.4 meter. So this is the final answer, guys. So the straight track covered by the insect, that's the resultant, that's the answer. And the angle above the horizontal is 33.7 degree. Now let's move on to the example 2. So in this example, guys, the question says that consider a vector of magnitude 3 units and the direction of plus x-axis. This is followed by another vector of 4 units parallel to the plus y-axis. What is the resultant of the vector? Guys, we don't have any problem here. What we're going to do now is that, you see, they say plus x-axis. So we just remember that this is your plus x-axis. This is the plus x-axis, and that is what? 3 units. And followed by another one which is parallel to the plus y-axis. This simply means that we have the plus y-axis. This is the plus y-axis. That is what? 4 units. That's it. So this is the plus x-axis. This is the plus y-axis. This one is 3. This one is 4. Calculate the resultant of the two vectors. If you want to calculate the resultant, we will just, since they are acting at angle 90 to each other, so the resultant can be done like this. This is the resultant. So we just use r is equals to square root f1 square plus f2 square. That's equals to square root 4 square plus 3 square. That's equals to square root. 4 square is 16. 3 squared is 9. 16 plus 9, that is what? 25. That's square root 25. And that's equals what? 5 Newton. So the resultant is what? 5 Newton. But I can also calculate the what? The angle. The angle. So I'll just say that, I'm going to represent this as angle theta, angle to the horizontal, this as theta. So my theta will just equals to tan inverse summation y over summation x. That's tan inverse summation y, that is 4, and x, that is what? 3. So don't forget, this is the x, this is the y. And this gives me, so guys, this gives us 53.1 degree. Thus, we are going to say that the resultant displacement is 5 units. The resultant is 5 units. And it makes an angle of 53.1 degree with the plus x-axis. You know that this theta is to the plus x-axis. Do you get that? But if you want to look for the angle it makes with the plus y-axis, you are going to represent this. You know, this plus y-axis, you are going to represent this as alpha. Are you there? So if you want to get this alpha, you just know that sum of angle in a triangle equals what? 180 degree. So this simply means that alpha plus theta plus 90 degree is equals to 180 degree. Don't forget, this is alpha. This is alpha. This is theta. This is 90 degree. So this simply means that alpha plus theta can equals to 90 degree, because 180 minus 90 give us 90 degree. So therefore, your alpha will be equals to 90 degree minus 53.1 degree. Then alpha is equals to, now you want to do 90 degree minus 53.1 degree, gives me 36.9 degree. So this simply means that, or an angle 36.9 degree with plus y axis. Thank you guys.